Great. Welcome back. We're looking at some problems here that have negatives and positives involved. The key idea for this is that we can take and add blocks that negate each other out. So I can have positive x and negative x. I can add it to my tile base, and those really cancel out and negate because those equal 0. Okay. So the sum of everything doesn't change if we add these up. Okay. Well, let's look at this. X squared minus 6x plus 5. For simplicity, I'm going to put x squared in the top corner. And then how many of those negative x's do I need? This one's actually a little easier to start with. 6. Think about how you're going to configure them. How are we going to configure them in order to have space for 5 more? What do you think? Negative x, negative x, negative x, negative x, negative x, negative x. Okay. I want to think about this when I'm putting in my negative 6x tiles. Putting in the negative 6, I want to make it so that I can fill in what's left. This gap here, I can fill it in with whatever my constant value is. And the constant value here is 5. So I go in 1, 1, 1, 1, 1. Put 5 of them in there. I've made it into a rectangle. Again, making it into a rectangle shape is the key. So this one worked out nice. And we can look and see that this is an x by x. So we have dimensions for this top box of x and x. If this dimension is x for my negative x box here, then this is a negative 1. X times negative 1, negative x. So that has to all match. Okay. We have a negative 1, because this is x. Now here's the deal. How can we get 1? What two numbers multiply to give us 1?
1 and 1.
1 and 1, or?
Negative 1.
All right, we know that all these are negative 1, so in order to make and to balance with this negative 1 up here, this has to be negative 1 as well. Sometimes, when you work this out, you have to look really close. The reason I got the hint on this was, this is a negative x tile here. Since this is x, that's not changing because this upper box is x squared. That's an x, so this has to be negative 1. Okay? Since that's negative 1, that told me that this down here has to be negative 1. And then I'm thinking, how do I get 1s? Those are all going to be positive, or excuse me, negatives as well. So let's do the, what is that length?
X minus 5.
X minus 5. And then, what is this length?
X
Minus 1. So we got this as x minus 1, x minus 5. If you did that out, you FOILed it. So the good thing is when you have these problems, when you get to the assessment, you can have these problems and know 100% if you got it right. What do I do to find out if it's 100% right? Yeah. Let's go and do FOIL to double check. First, x squared, outer minus 5x, inner minus x, last plus 5, x squared minus 6x plus 5. That matches. Yep, we got it right. Okay. So what did we learn from this problem? We learned that sometimes to get a positive 1, we're multiplying negative 1 times negative 1. And remember my hints were, these were all negative values over here, so they have to be over there. This was a negative value from the negative x, so it has to be a negative, and then it all works out nice. Yes.
Without algebra tiles, how would you be able to find out what the...
How would you? Remember we did, no, you were here for this. We would put 5 down here, we'd put negative 6. We'd find two numbers that multiply to give us 5 and add to give us 6. And let's try what we have, negative 1 and negative 5. Does that work? It does. So then I would know I'd put those right into there. We did the X method last semester. So the X method is, and again, we're using algebra tiles to get used to it. We're using algebra tiles to get used to it because next week we're dealing with these problems that have 2x squared plus you know, 4x plus 16. That's not real. I don't even know. This was really hard to do the x method. Remember we had to do the super x method? We're basically not going to revisit that at all. We're going to get this with algebra tiles like that. We're going to do the completing the square, which took a lot of effort. Remember the b over 2 squared, all that stuff? We're going to do that using algebra tiles. We get it like that. Okay? So I know that this is kind of cumbersome because you're like, oh, I could just do the x method. But we're learning on these because next week we're going to go a little bit deeper. Hopefully, when you're doing both methods, you'll be able to see how they work out spatially. So I'm good at math just because of spatial. I'm good at music just because of spatial. Right? You have different types of intelligence that work together. I'm getting on a different one right here. This is spatial instead of just mathematical. Okay. Let's try this one. What do I put in the top left corner? X squared. Just for simplicity, if some of you are ready to get creative, you can put it in the middle and work around it. We'll have to do that when we get to these. We'll have to work from the inside out. What else do I have up here? I have negative 5x's and plus 6. Okay. So I'm looking at this. I'm going to start off by doing this. It's just a hunch, but you can go on hunches at this point because you can just erase it. I'm going to say that all my negative x's are down here. Now I want you to think of the rule that we just brought up, how we have an x and a negative x, and how those two negate out. What can I add to this in order to also get enough space to put my negative 6 in there? Yeah, Jesse? You can add 2 and 2. That would give me 7. Oh, I see. So you're saying just take these 3 and put them up here. All right, let's see what happens. So I was thinking another route, but maybe this is the way to go. I'm going to just put 2 here. Let's see if this works. Negative 1, negative 1, negative 1, negative 1, negative 1, negative 1. Can anybody tell me why this doesn't work? Yes.
Because for negative x, that'll be negative 1.
Right.
X.
Those are the dimensions of those.
And that would mean the other one would be negative 1.
Right, then this would have to be negative 1s. But then, how about these up here?
Those are also negative 1.
Those are negative 1s up there.
And then if it's negative 1.
This negative 1, that's not going to work out because negative times a negative doesn't give us a negative. So I like that approach. Sometimes you're going to get to it and the tiles look like they work, but just make sure, double check everything out. This is next level. No worries, don't worry. Don't worry. Hear the worry. That's an audible sound. I'm going to go back to what I had. If you missed that, that's something to recheck on the video. Carlos.
It's going to be negative 6x on the bottom, and then positive x on the side.
Yes. We're going to add a negative x there, a positive x there. Those would negate out. But what does this allow me to have as far as empty spaces? There we go. Let's see if this works out. It looks like it will because we need the positive and the negative here. All right. We know that this is x. So this has to be 1 because that's 1 times x to give us that x. That has to be a 1. So all these have to be negative 1s. This has to be negative 1s then. All right, that's x. That's x. That's x. That's x. If you're having a hard time with this, then my challenge is, for this problem, if that kind of stumped you on what we were doing, I want you to put what the values of the dimensions all around the whole outside. That's going to help you see if the dimensions don't work out. Okay. This is the one tricky part. When the negatives are involved, you have to make sure that you're really looking how the tiles are fitting. But now it's easy. So Alan, what is this dimension?
X plus 1.
All right. What's this dimension?
X minus 6.
So we get x plus 1, x minus 6. I'll do fast forward. Yeah, that's right. just looks like I wrote it down again. But FOIL it out, we do get where we started, so we're good to go. All right, last one, Mark.
With the first one that wasn't correct, the side lengths, I ordered them out, and they were equal to the original.
You had 2, so we had, it was x plus 2, x plus 3.
I got x minus 2, x minus 2.
That would make them positive 6. Because it's negative 3 times.
So that's why it wasn't working out. But when you FOIL it back, you can see the trinomial didn't match, so you have to go another route. There's a bunch of places to catch yourself with this. Last one here. X squared in the top left box. I know we're going to have to add a bunch here, because I look here, there's only one negative x. So we're going to add quite a bit to this. Who has an idea? Yeah, really.
Okay, I added 3 negative x's, and then I added 3 positive.
So I like that you did that. Can you give us a hint why these dimensions help us get 12?
So 3 times 4 is 12, and we needed to cancel out, like, you know, the negative x that you added, so you added the positive x's, so that all works out. You have the boxes that are by ones, one side is negative and the other side is positive.
Oh, okay, so you went all the way with that rationale. That's great. Let's put this as -1, -1, -1, and so on. Okay. Now, as an exercise for everybody, let's try to put the dimensions all the way around this. I know that this is x. I know that's x. I know that's x. I know that's x. Those are all x. No? You want to help with it, Jackson?
No, I'm good.
No? Sure?
I was trying to figure it out.
Okay. So go ahead and try to put those dimensions around it. These are just positive x's, right? Positive x's. 1, 1, 1. These are negative x's. That tells me that this is -1, -1, -1, negative. I just want to say it a lot. I ran out of it. So I know that these have to be my negatives because they always match on both sides. 3. So in order to get this -1 box, it's -1 times a +1. So those are all my dimensions all the way around. If they all match, top and bottom match, left and right match, you know you got it right. There's like 5 ways to check if you got it right. So let's see, who wasn't here yesterday? Justin. Can you tell me the dimensions on the bottom? X. 1, 2, 3. What? You want to call? You want to phone a friend?
Yeah.
You got to ring him up. Pick up, man. He's calling you. Okay, speakerphone. 1, 2, 3. Okay. Good?
Yeah.
All right, good. Let's see. Who else wasn't here? Rafsha, what's this dimension here?
X minus 4.
Ooh, with confidence. X plus 3, x minus 4. And we're done. Those combine to give us first x squared, outer -4, then plus 3, minus x. Last, minus 12. Okay. All right. Thumbs up, thumbs sideways or down for negatives. It's the hardest leap we got to make all the next 2 weeks. Okay, so far so good. All right, good.
Oh, that was negative?
Yeah, now we know how to deal with negatives. Yeah, I mean, what else is there? All right, so I have an important announcement. We got past 79.
Yeah.
hasn't subscribed? I'll close my eyes. Raise your hand if you didn't subscribe. Is that a lot of people?
Yeah.
Is it more than half?
It's like
Yeah.
3/4.
All right, put your hands down.
3/4.
Put your hands down. Still up. All right. Everybody subscribe because there's going to be a moment when you don't have everything down. It's going to make it quicker to get to the videos. Or if you miss class, you don't have the iMac, you can get to the videos at least. Just subscribe. And also, number 123, number 123 gets something special. They get a whole, what do you call it? Not container.
Basket.
A thing, a box
What?
of Oreos. Oreo cookies. A package.
Smart.
You're going to get a package of Oreo cookies, and it's because Oreos are vegan, so if I have a vegan student.
Is it double stuff?
You want double stuff?
Yeah.
Make it mint.
Okay, a package of double stuffed Oreos
You get fish.
to the 123rd. So I got to come up with jokes that are 1, 2, 3 now.
No, it should be 123 Oreos. Oh, I have a joke.
What is it?
I have to write it on the board, Joe.
Subscribe
next
now.
time.
He needs the YouTube money.
That's right. All right, let's do subscribe 1, 2, 3 on 3. 1, 2, 3.
Subscribe.
Support Mr. Shane's channel.
Bye.
Please help.